When we encounter trinomials where there is not a 1 in front of the x squared, for example, number 1 from your assignment, we can use any of the 3 methods that we talked about for simple trinomials. It's just trickier. Okay, so what we do use is something called decomposition. Now, for decomposition, we usually use a bit of the reasoning. So I like to draw the x. We're looking for what multiplies to a times c. Okay, when we talk about a, we're meaning the number in front of the x squared. C means the last constant term. So a times c in this case is 24. We're looking for 2 numbers that multiply to 24 and add to the same, the b, the 10. Okay? Now if you want to jot that in, this is a times c, and this number was b. Okay, when we're looking at this standard form for this trinomial. Okay, and so let's try to find 2 numbers that multiply to 24 and add to 10. You can brainstorm this in your head and see if you can come up with them if you want to do some writing. So numbers that multiply to 24 would be 12 and 2, obviously 24 and 1. We've also got 6 and 4. We've got 8 and 3. I think that's all of them. And then, of course, if they're both negative, that would work too. Now, any of these seem to add to 10? Well, yeah, this one. Okay, so the 2 numbers that multiply to 24 and add to 10 are positive 6 and positive 4. Now, we use that. We go back, and the second step in decomposition is to rewrite the middle term, this 10x, broken into 2 parts, the 2 parts that we found. So now I'm going to break 10x into the 6x and the 4x. That's the 2 numbers we found, and then plus 3. Okay, so we're not changing the question. We still have 10 x's. We've just broken them into 2 parts. The third step of decomposition then is to consider a common factor for the first 2 terms and a common factor for the second 2 terms. This is where your common factor comes in handy. So, common factor for the first 2 terms here, I see a 2 and an x. What am I left with then? 8x squared divided by 2x gives me 4x. 6x divided by 2x gives me 3. Good. Let's look at the second binomial here, the second part. No common numbers, no common variables. So if there's nothing in common, we say we take out a 1. We say plus 1, and 1 times 4x plus 3. Now, in decomposition, this is always going to happen where, and if it doesn't happen, we've messed up somewhere. The part in brackets, after you've taken out a greatest common factor, it should match. Okay? Because now we're going to look, the 4th step then of decomposition is to look as what's common at this binomial. So this is actually a binomial because it has 1 term and 2 terms. So the terms are quite long, right? But we're looking for what's common between term 1 and term 2. Well, the part that I highlighted, right? The part in the brackets. So we take out that common, greatest common factor of 4x plus 3. And what are we left with in this first term? If we take the whole yellow part out, we're left with the 2x. And if we take the yellow part, our greatest common factor, out of the second term, we're simply left with the 1. And there is our answer for decomposition. 8x squared plus 10x plus 3 can be factored to find those 2 factors. Now, of course, you can check, which I recommend you always do, because then you'll never get anything wrong if you've made sure you've checked. So what we need to do is FOIL this, or multiply it back together. if I multiply this, remember first terms, 4x times 2x is 8x squared. Outside terms, 4x times 1. Inside terms, 3 times 2x. And last terms, 3 times 1. Okay, I can already see that this is going to add to 10x in the middle, and yes, this is what we started with, meaning we did factor correctly.